So hello everyone. So this is one final video of the state space analysis. Till now we have covered all the concepts starting from state space model, that is simple electrical network. Then we have seen state space model of differential equation, transfer functions. In previous video we have seen with the signal flow graphs. Everything I have covered. Now one final concept is left, that is state transition matrix. Again, this is very simple, yet some questions are very lengthy ones. The first question is very simple, easily you will be getting the solutions, but the second question is a bit lengthy but very easy. Let us see how the problems can be solved under state transition matrix. So we have two formulas, straightforward formulas for state transition matrix, very simple ones. That is, first is STM, state transition matrix, is represented as phi of t. Okay, phi of t, since it is in the time domain, so since from S domain to time domain we should be converting it, so we should be doing the inverse Laplace transform, that is we should be doing the L inverse of Si minus A inverse. So whatever, first you should be finding Si minus A, then Si minus A inverse, then whatever answer we get, you should be taking the inverse Laplace transform of that. You will be getting in S domain, you should be converting it into T domain. Similarly, inverse state transition matrix ISTM is given simple way, that is phi inverse of t. Since the final answer we get it in the form of matrix, so matrix inverse condition, as you know, that is adjoint of matrix divided by determinant of matrix, that only applies for this formula also. Okay, straightforward formulas, problems are also straightforward. So without wasting any time, let us solve these two problems. Direct questions they would be asking in the exam also in the same way. Find the state transition matrix for A. They would be giving you one matrix. That should be, you should be considering that as A matrix. Okay, so these are the two problems. This is the first problem where they have given the value of A as 1 0 1 1. So now put the formula of state transition matrix. Phi of t is equal to L inverse of Si minus A inverse. Okay, so now here first solve for Si minus A. S into I is the identity matrix minus A in the given question, that is 1 0 1 1. So multiply S minus 1 0 1 1. So Si minus A would be equal to S minus 1, 0 minus 0 is 0, 0 minus 1 minus 1, S minus 1. So this is Si minus A. Now we should be doing the Si minus A inverse, right? So Si minus A inverse, that is equal to adjoint of Si minus A. Adjoint of Si minus A, as I have told you many times, that is diagonal terms should be exchanged. That is, in this case the diagonal terms are one and the same, so that's why it is S minus 1 only. And the non-diagonal terms, signs should be interchanged. That is, this would be plus 1 and this is 0. Divided by determinant of A, that is S minus 1 into S minus 1 minus 0. 1 into 0 is 0. So this is the Si minus A inverse. So now what I am doing is, I am dividing S minus 1 into S minus 1 to this whole matrix. So what I am doing is, see here, S minus 1 divided by 0 divided by this is 0 only. So this is 1 by S minus 1 into S minus 1, S minus 1. So I have divided this term to this whole matrix. So here one S minus 1 would be getting cancelled here and here. Okay, so our final answer would be looking like this. Is equal to, so first we have 1 divided by S minus 1, 0. Then here we have 1 divided by S minus 1 into S minus 1, that is S minus 1 whole square. And here we have 1 divided by S minus 1. So this is the Si minus A inverse. Now the final step is left, that is you should be taking the inverse Laplace transform, right? According to the formula, take inverse Laplace transform LT, that is L inverse of Si minus A inverse. So here, before taking the inverse Laplace transform, you should be knowing the L inverse Laplace transforms. Here this is of the form 1 divided by s minus a. Okay, you see here L inverse of 1 divided by s minus a could be written as e to the power at. Okay, so here in this case, in place of a we have 1 here in these two values, so this would be replaced by e to the power 1t or e to the power t. So here I am writing it as e to the power t, this is 0 only, and here we have 1 divided by s minus 1 the whole square. So according to the condition, L inverse of 1 divided by s minus a the whole square is equal to t into e to the power at. Okay, so in this case t into e to the power 1t, that is t only. So this is the inverse Laplace transform, and this is the final phi of t which you have got in the time domain. So this is the answer for state transition matrix. So for this, let us try to take the inverse of this also the same way. So inverse is phi inverse of t, that is adjoint of phi of t divided by determinant of phi of t, that is adjoint of this means these two would be interchanged. So since those two are same, so it is one and the same. Here also this would be minus t to the power t into e to the power t, and this is 0 divided by determinant. So these two into minus these two, so this is 0. E to the power t into e to the power t, that is it is of the form e to the power a, e to the power p, that is equal to e to the power a plus b. So here it is e to the power 2t, t plus t is 2t, right? So our final matrix would be looking like inverse matrix e power t divided by e power 2t, 0 minus t e power t divided by e power 2t, e power t divided by e power 2t. So this is the phi inverse of t. So in this way we should be taking the inverse of the state transition matrix if they ask. Otherwise mostly they would be asking only the state transition matrix. Very simple. This was one simple problem, and the second problem now, that is very complicated. Okay, there are a lot of partial fractions to be done, so let us solve that. A bit lengthy but very easy. Okay, let us solve that. So this is a question, transition matrix formula. Let us solve it now. First, start with Si minus A. S into I is the identity matrix, minus A, 0, minus 1, 2, minus 3, multiply S, so finally Si minus A is equal to S minus 0 is S, 0 minus of minus 1, that is plus 1, 0 minus 2 minus 2, then S minus minus 3, that is S plus 3. So this is Si minus A. Now we should be taking the inverse adjoint of Si minus A. Replace the diagonal terms, interchange. This is S plus 3, this is S. Non-diagonal term signs are changed. So this is plus 2 and this is minus 1 divided by determinant S into S plus 3, that is S square plus 3S. Then we have minus of minus 2. Minus of minus 2, that is plus 2. So here we got S square plus 3S plus 2. Now factorize this term x square plus 3s plus 2. Let us see the roots here now. So s square plus s plus 2s plus 2. So s into s plus 1 plus 2 into s plus 1. So the roots are s plus 1 and s plus 2. So this would be written as s plus 1 and s plus 2, right? So now should be writing it that way now. Si minus A inverse. So divide this term here to this whole matrix, that is s plus 3 divided by s plus 1 into s plus 2 minus 1 divided by s plus 1 into s plus 2, 2 divided by s plus 1 into s plus 2, s divided by s plus 1 into s plus 2. So you see here, these are all under condition of partial fractions, all the 4 elements. So sometimes there would be, some questions would be like this also. So like that, for each and every one you should be applying the partial fractions, finding the value of a and b, then separately writing it, and finally you should be doing the inverse Laplace transform. Okay, so one by one for each term now you should be finding. So the first term, s plus 3 divided by s plus 1 into s plus 2. So Laplace partial fraction, that is a divided by s plus 1 plus b divided by s plus 2, right? So cross multiply a into, so I hope you know how to do the partial fractions. So that also I should teach you guys now, no, right? Yeah, so I won't waste much time on partial fractions. B into s plus 1 divided by s plus 1 into s plus 2. So denominator would be getting cancelled, so you would be left with s plus 3 is equal to a into s plus 2 plus b into s plus 1. So if you don't know how to do partial fractions, I have already done in third sem the videos. Go and watch it. Okay, it is available. I can't teach partial fractions now. So now we should be finding the values of a and b. So how you should be finding? You should be doing the b value equal to 0 such a way that you should be substituting the value of s. So here, if you want to make this b equal to 0, you should be substituting this as minus 1. Okay, so you should be putting s is equal to minus 1 first. Put s is equal to minus 1, that is s plus 3, right? So minus 1 plus 3 is equal to a into s plus 2, a into minus 1 plus 2, and b is equal to 0. Okay, since we have put minus 1. So this is 2 a into 1, so a would be equal to 2. Similarly for b, if you want to find the value of b, a should be making it equal to 0, so we should be putting this as minus 2. Okay, so s is equal to minus 2, so the equation would be minus 2 plus 3 divided by b into s plus 1, so minus 2 plus 1, so minus 2 plus 3 is 1, b into minus 1, so b is equal to minus 1. So our equation would be looking like s plus 3 divided by s plus 1 into s plus 2 is equal to a is 2 divided by s plus 1 plus b is minus 1, so minus 1 divided by s plus 2. Okay, so for one we have replaced it for one term. First term is done. Now for second term, the same thing. Second term of the matrix is minus 1 divided by s plus 1 into s plus 2. Again do the same method, partial fraction, cross multiply, cancel out the denominator, we are left with minus 1 is equal to this is the equation. In this you should be finding a and b values such a way that other term should be equal to 0. So if you want to find a, this term should be 0, such a way you should be substituting the value of s. So here it is minus 1. So first put s is equal to minus 1 in this equation. So minus 1 is equal to a into minus 1 plus 2. So b is or 0, so no need. Minus 1 is equal to minus 1 plus 2, that is plus 1 a. So our a would be equal to minus 1. So now put s is equal to find the value of b, this should be 0, so this should be minus 2. Minus 1 is equal to b into minus 2 plus 1. Minus 1 is equal to b into minus 1. So minus minus goes, so our answer is plus 1. So minus 1 divided by s plus 1 into s plus 2 would be replaced by a value is minus 1 by s plus 1 and b value is plus 1 by s plus 2. Okay, so two more terms are left. Do that. Third term, 2 divided by s plus 1 into s plus 2. Again the same partial fraction method, cross multiply, cancel out the denominator. 2 is equal to a into s plus 2 plus b into s plus 1. So here first find the value of a, so this should be minus 1. Put s is equal to minus 1. 2 is equal to a into minus 1 plus 2. So 2 is equal to a into plus 1. So a is equal to 2. So now put s is equal to find the value of b. This should be 0. So this is minus 2. So 2 is equal to b into minus 2 plus 1. 2 is equal to minus 2 plus 1 is minus 1. So b is equal to minus 2. So therefore 2 divided by s plus 1 into s plus 2 would be replaced by 2 divided by s plus 1 a and minus 2 divided by s plus 2. So this is for third term. Now finally do for fourth term also the same thing. S divided by s plus 1 into s plus 2. Cross multiply. Cancel. We are left with s is equal to a into s plus 2 plus b into s plus 1. So first find the value of a. For that this should be 0. This should be minus 1. Put s is equal to minus 1. So minus 1 is equal to a into minus 1 plus 2. Minus 1 is equal to a into plus 1. So a would be equal to minus 1. Now put, to find b, this term should be 0. This should be minus 2. Minus 2 is equal to b into minus 2 plus 1. Minus 2 is equal to b into minus 1. Minus minus goes, so b would be equal to 2. So the final term, s by s plus 1 into s plus 2 would be replaced by minus 1 by s plus 1 plus 2 by s plus 2. So these are the four terms which are replaced. Now let us write it in the matrix form, all the four terms which I have done the partial fractions. So I have replaced all the terms after doing the partial fractions, whatever values I have got for a and b, and I have written it in the matrix. So this is not yet. One final step is left, that is the taking inverse Laplace transform, right? Finally you would be getting our phi t, that is equal to 2 by s plus 1. Again this is of the form 1 divided by s plus a. You see here 1 divided by s plus a, that is e to the power minus at. E to the power minus at. Okay, so here we have minus 1, so plus 1, so it would be minus 1, and 2 we have here, so 2 into e to the power minus t minus again e to the power minus 2t, because we have 2 here. This is one term. So next term again minus 1 by s plus 1, so minus e to the power minus t plus e to the power minus 2t. This is the second term. Third term 2 e to the power minus t, the same thing. minus 2 e to the power minus 2t, third term, minus e to the power minus t plus 2 e to the power minus 2t. So this is the final transition matrix phi of t. So if you want, you can take the inverse, and if they ask who doing the inverse, so since the video is lengthy, I am not going to do it. It's very easy. Do the adjoint of this, that is interchange these two, replace the signs of these two, then divided by the determinant. Okay, do that and find the phi inverse. That's the homework for you guys. For this problem, find phi inverse of t. So yeah, that's all guys. All the concepts I've covered of module 5. Now there should be no complaints regarding module 5. Everything I've covered. Okay, so my job is done. Everything I've covered. Now it's your job. One day is left. Give it your all. Watch all the videos. Do not sit steady. Do not sit lazy. Do practice these sums day and night. Day and night you should be practicing, because these problems are very important. Multiple times repeated, and practice is must. If you don't practice, if you do the mistake also, you will not understand in the exam if you don't practice. At least if you practice, right, if you do some mistakes, right, you would be understanding where you have gone wrong. So that kind of subject is this. So please do not stay lazy. Do practice. And yeah, that's all guys. Hope you enjoyed all of my videos. So my job is done. All modules are completed. Check it out and subscribe. Subscribe to our channel, it is must. Okay, thank you.